Join me as I dive into the mind-bending world of quantum mechanics and see if I can figure out whether time travel could actually become a reality. Time travel, a staple of science fiction, has long fascinated us with its endless possibilities and mind-bending implications. From H.G. Wells to Doctor Who, we've seen countless depictions of time travel in literature, film, and television. But today, we're going to take a step back from the realm of fiction and explore whether time travel could actually become a reality, and if so, how quantum mechanics might hold the key. Time travel, if it were possible, would raise a multitude of scientific and philosophical challenges. For starters, it would require a thorough understanding of the fundamental laws of physics, which, as we know, are still largely governed by the laws of classical mechanics. We'd need to reconcile the grandfather paradox, where a time traveler goes back in time and kills their own grandfather, thus preventing their own birth. But if they were never born, who killed the grandfather? Then there's the issue of causality, where cause and effect become muddled, and the fabric of space-time begins to unravel. The laws of physics, as we currently understand them, seem to suggest that time travel is impossible. The fundamental laws of thermodynamics, electromagnetism, and gravity all conspire against us, preventing us from warping the fabric of space-time in such a way that would allow for time travel. And yet, despite these obstacles, some of the most brilliant minds in physics have proposed theories that attempt to sidestep these limitations. One of the most significant hurdles in reconciling quantum mechanics with time travel is the problem of decoherence, where the interaction between a quantum system and its environment causes the loss of quantum coherence. In other words, when a quantum system interacts with the outside world, it ceases to exhibit quantum behavior. This makes it incredibly difficult to scale up quantum effects to the macroscopic world, where we live. But what if I told you that there's a way to potentially bypass these limitations? Enter quantum mechanics, the strange and counterintuitive realm where the rules of classical physics no longer apply. Here, particles can exist in multiple states simultaneously, and the act of observation itself can change the outcome of a measurement. In the realm of quantum mechanics, the concept of wormholes takes center stage. Wormholes, hypothetical tunnels through space-time, could potentially connect two distant points in space, allowing for faster-than-light travel, and, by extension, time travel. The idea is that if we could create a stable wormhole, we could use it to travel through time, visiting eras past and future with relative ease. But that's not all. Quantum mechanics also challenges our classical understanding of time itself. According to the theory of relativity, time is relative, and its passage depends on the observer's frame of reference. The faster you move, the slower time passes relative to a stationary observer. Take this idea to its logical conclusion, and you begin to realize that time is not an absolute, but rather a dimension that can be warped and manipulated. One of the most compelling theories that suggests time travel could be possible is the concept of quantum entanglement. In a quantum system, when two particles become entangled, their properties become linked, regardless of the distance between them. This means that if something happens to one particle, it instantly affects the other, even if they're separated by billions of miles. This phenomenon has been experimentally confirmed time and time again, and it has far-reaching implications for our understanding of spacetime. If we could entangle particles across different points in spacetime, we could potentially use them to send information through time, effectively allowing for communication with the past or future. And that's when things start to get really interesting. Imagine being able to send a message to your past self, warning them about an impending disaster or sharing knowledge that could change the course of history. Or picture being able to receive a message from your future self, containing knowledge that could solve some of humanity's most pressing problems. The possibilities are endless, and it's enough to make your head spin. So what does this all mean? In conclusion, while time travel remains purely theoretical, the concepts of quantum mechanics offer a glimmer of hope that one day we might be able to unlock the secrets of the time stream. From wormholes to entanglement, the strange and counterintuitive realm of quantum mechanics holds the key to making time travel a reality. Thanks for joining me on this mind-bending journey through the world of quantum mechanics. If you have any thoughts on time travel or think you can come up with a solution to the grandfather paradox, drop a comment below. And if you want to stay up to date with the latest breakthroughs in science and technology, be sure to subscribe and hit the notification bell for my next video.